Hello everyone. Today we are going to have another look at linear equations for the purpose of graphing these linear equations. Graphing linear equations means plotting the linear equations on an xy coordinate plane. So the first step that you need to take before plotting a function is a linear function is you have to know how to recognize a linear equation when you see one. So any equation which has a degree of 1 will be a linear equation. I have noted down a few examples of linear equations. Y equals to 2x plus 5, 3x plus 4y equals to 12, 3x plus 4y plus 7z equals to 84, and so on. These are all examples of equations with degree 1. I hope you remember how to find the degree of an equation. You basically calculate the powers of the variables appearing in each term of the equation. And the highest power that appears in the equation would be the degree of the entire equation. Just to give an example, suppose you have an equation of this sort. This polynomial equation has 5 separate terms. Now the degree of each term would be the total powers of the variables added up. So in 3xyz, x is raised to the power 1, y is raised to the power 1, and z is raised to the power 1. So the degree of 3xyz will be 1 plus 1 plus 1, 3. In the second term, 4x square yz, the power of x is 2, the power of y is 1, and the power to which z is raised is 1. So the degree of the term 4x square yz will be 2 plus 1 plus 1, which is 4. Similarly, in 4xy, the degree will be 2, and 3x square, the degree is also 2. The rightmost term is a constant, so its degree would be 0. Now, the degree of this entire equation will be determined by the highest number that we see here. So, this particular equation that I have given as an example is an equation of degree 4. Okay, and I am saying that any equation of degree 1 is called a linear equation. Okay, so you may have a linear equation in one unknown variable, 2 variables, or more than 2 variables. However, since we are trying to look at how to plot these linear equations and we have only a 2-dimensional axis, that is, your coordinate plane looks like this. The horizontal axis is called the x-axis, your vertical axis is called the y-axis. So since we are talking about plotting linear equations, remember that we can only plot a linear equation in 2 variables, such as these 2. Now, moving on to the special case of a linear equation in 2 variables. Like I said earlier, we are interested in these because these are the ones that can be plotted on an xy coordinate plane, right? So the general form of a 2-variable linear equation is y equals to ax plus b. At least some of you might have studied this even in your plus 2 maths. Some of them studied in this manner: y equals to mx plus c. It is the same form. Instead of m, over here I have written a. Instead of c, I have written the letter b as the parameter of the equation. You can use either of these forms because They're not very different, but remain consistent in which notation you're using. If you're calling the slope of the line A, make sure you're consistently calling it A. If you're using this form mx plus c, then remember that slope is represented by m and the y-intercept is represented by c. So I'm going to continue with this general form, which I have already typed into the PowerPoint presentation. So the general form is y equals to ax plus b. It's a equation of degree 1, so it is a linear equation. And if I try to plot this on the coordinate plane, I will get a straight line. Here the coefficient of x, that is a, is called the slope of the function, and the constant that appears in this equation, that is b, is the y-intercept. Let's understand what slope and intercept mean by looking at the graph. So here is a line that I have drawn on the xy coordinate plane. It is a straight line. I am saying that this is ax, y equals to ax plus b. Now, the slope is a measure of the angle that the straight line makes with the x-axis, with the positive, in the positive direction. So in this particular line, as you can see, even though the line is drawn only till here, I can extend it with dotted lines, and theta here is the angle that this straight line makes with to the x-axis. Tan of theta is the slope of the equation, and if you look at the equation, its numerical value, that is the slope numerical value, or tan theta, is equal to a. What does intercept mean? It means the point on the y-axis. Remember, b is the y-intercept. So it is the point where the straight line meets the y-axis. So as you can see, this point over here will have the value 0, b. So now that you have figured out what the slope and the intercept terms mean, you can always represent any linear equation in the general form and report back the slope and intercept. For example, suppose you have an equation written like this. Say 2x plus 4y equals to 12. Now this is not in the general form of y equals to mx plus c or y equals to ax plus b. If I ask you to find the slope and intercept, your first step would be to express this particular equation in the general form. So I can do this like this: 4y is equal to minus 2x plus 12. I took positive 2x to the right hand side, so it has become negative. Now remember, I want y to have a coefficient 1. Okay, so what I have to do is y is equal to minus 2x plus 12 whole divided by 4. This is because on the left hand side 4 had appeared multiplied to y. So when I shift it or push it to the right hand side of the equal to sign, it should come as a division. So it is minus 2x plus 12 divided by 4. Please note that when you have an entire expression divided, an entire equation divided by a number, this is the same thing as each term of the equation being divided by that number. So minus 2x plus 12 whole divided by 4 is equal to minus 2x by 4 plus 12 by 4. So I get y is equal to, since these cancel, minus half x plus this will cancel out to give me 12 divided by 4 is 3. So simply by transforming this equation into the general form, I can find out, I can understand what the slope of the equation is. So the slope of this equation is negative 1 by 2, and the intercept, even though I use the term intercept, remember I mean the y-intercept. That is, it is the point at which this particular function, if I plot, will cross the y-axis. Y-intercept is equal to b, or 3 in this case. Now remember, y-intercept is the value of y when the value of x equal to 0. What I mean is, suppose I have drawn this function. This point is the y-intercept, and if you look at its coordinates of the point, remember we'll always note the coordinates as x comma y. Value on the x-axis, x coordinate, comma y coordinate. So this point will be x value is 0, comma the y value is b. So you can also find the y-intercept by putting this x value equal to 0. Okay, so you can use either of these methods, you will get the same answer. If I put x equal to 0 over here and solve for y, I'll get y equals to 12 by 4 equals to 3. So you have just confirmed or verified that the y-intercept is equal to 3. But like I said, even easier method, instead of doing so much calculation, is to convert it into the general form. In that case, the coefficient of x will be your slope and the constant will be your y-intercept. Now let's have a quick look at how to plot a specifically given linear function or linear equation. What I have here is minus 4x plus 2y equals to 8. So this is a linear equation because the degree of the entire equation is 1 and there are two unknown variables x and y. So if it's a linear equation and it is in two variables, I can definitely plot it on an xy coordinate plane. Now I'm going to show you one of the simplest methods. There are different approaches that you can take. So first what I'm going to do is I'm going to convert this equation into the general form of y equals to ax plus b. So I'm keeping 2y is equal to negative 4x goes to the right hand side, so it is 4x plus 8. So I can write this as y is equal to 4x plus 8 whole divided by 2. Remember, that means it is 4x by 2 plus 8 by 2. So your general form equation is y equals to 2x plus 4. That is, I'm left with 2 here and this cancels to get 4. So this is my equation represented in the general form. So equation 1 and equation 2 represent the same function, only the form looks slightly different. Okay, 1 and 2 are one and the same function. Now, how do I go about plotting it? Remember, to plot a straight line, you need a minimum of, or at least, coordinates of 2 points, okay, on the x and y axis. So the vertical line is the y axis, the horizontal or sleeping line is the x axis, okay. This entire plane is called the coordinate plane. And the value along the x-axis is called the abscissa. The value along the x-axis is called the abscissa. And the value along the y-axis is called the ordinate. These are the technical terms. And remember, the location of any point is recorded as the value of x, comma, value of y-axis, that is abscissa, comma, ordinate. Now, so suppose I want to plot the point 2, 4. I will need to okay, remember these points should be equidistant. Use a scale and a pencil. I am doing it with a magnetic pen, that is why it is not as perfect as I would like it to be. Okay, so once your axes are labeled and the scale is measured out, the location of point 2, 4 will be 2 against the x-axis and 4, okay, 2 against the x-axis and 4 against the y-axis. So your point is located here, 2, 4. So every pair of values, that is every pair of abscissa and ordinate, give you the location of a point. A point such somewhere here has the x-axis value as 5, so the abscissa is 5 and the y-axis value as 2. To confirm, you can just check this. On the x-axis the location is 5, on the y-axis the location is 2. Okay, once again I apologize that this graph is not as perfect as I would like it to be. If you are drawing this with a ruler and a pencil, you will get it much more neater. Okay, so remember, you have to use a ruler and pencil to plot these lines. So now that you have understood what the coordinates are and how we represent location of various points, we need at least or a minimum of 2 points to be able to plot a straight line. So if we have these 2 points and we are trying to plot a straight line which contains these 2 points, all I need to do is take a ruler, join these 2 points with a straight line, and then I can extend it further as much as I want to represent the straight line. Okay, this line that I have just drawn is a hypothetical function. I am going to show you how to plot y equals to 2x plus 4 in 2 seconds. So now let me show you how to plot this line. Minus 4x plus 2y equal to 0. Minus 4x plus 2y equals to 8. To plot it, first I have converted it into the general form y equals to ax plus b. So I got it in the form y equals to 2x plus 4. Now I need to find the address or the location of 2 points. So take any value of x. Say the value of x I am taking is 0. So when assuming x equals to 0, I can calculate the value of y by putting the value x equals to 0 in my equation 2. So 2 times 0 plus 4, I get the corresponding y value as 4. So 0 along the x-axis and 4 units along the y-axis. That is 0, 4 is the location of the first point of this function. How do I plot it? When x is 0, the value is 4. So this is the location of the first point. Now let me assume any other value for x. Say x equals to 2. So when I assume x equals to 2, y will be, substitute the value 2 in equation number 2. So 2 times 2 plus 4. So that's 4 plus 4, which is equal to 8. So when the x value is 2, the y ordinate is 8. 1, 2, 3, 4, 5, 6. So I need to, this is 7 and this is 8. Now I know that when the x value is 2, my y value is 8. So, sorry. 1 second. So, this point here will be point 2, 8. Remember, it's the first term that I write is the value of on the x-axis. The second term that I write is the value on the y-axis. Now that you have got 2 points, 0, 4 and 2, 8, simply take a ruler. Okay, sure. That is not very straight line. So, simply take a ruler, draw a straight line connecting the 2 points that you have located and extend the line on either sides, and you will get your function minus 4x plus 2y equals to 8.